Alright, in this video we're going to talk about rationalizing denominators, dealing with square roots. So the idea is when you're simplifying things involving square roots, you do not want to have radicals on the denominator. So we'll start off with something relatively simple here. Let's do 1 over square root of 2. Now this is a case where you got a square root of 2 on the bottom. You can't take the square root of 2, but you can't have that on the denominator. So we're going to multiply this fraction by something that's going to cancel out that square root. And when you're doing square roots, it's pretty easy because all you do is you multiply the top and the bottom by whatever was on the bottom, which in this case was the square root of 2. And when you think about it, all we're really doing is multiplying by 1. So we're not changing what this problem is equal to, we're just changing the way it looks. So now we multiply across the numerators. 1 times the square root of 2 is square root of 2. And then when you multiply these two, square root of 2 times square root of 2, you're going to get square root of 4. Okay? And this doesn't look like we've done anything, but if you think about it, square root of 4 is just 2. So we've now rationalized the denominator, and our problem is now simplified. Okay? Let's do another example. Let's say we had, let's change up a little bit. Let's say we had the square root of, say, 3 over 5. Now I made this problem look a little bit different too, but if you know your properties of square roots, you know that I can rewrite this as a square root of 3 over the square root of 5. And we've got the same problem we had in the last one. We've got this square root of 5 that shows up on the denominator that we have to do something with. Having a square root on top is okay, but the bottom is what we're worried about. So let's multiply the top and the bottom by whatever is on the bottom, which in this case is the square root of 5. So in doing this, we just multiply across the tops again. 3, or square root of 3 times square root of 5 is square root of 15. Square root of 5 times square root of 5 is square root of 25. And just like the last problem, what we have on the denominator now should be a perfect square. In this case it is. Square root of 25 is 5. So your final answer is square root of 15 over 5. Alright, let's do one more example just to show you something a little bit different. Let's say that we had the square root of 40 over 7. Now 40 over 7 does not reduce, so we'll split this up into, let me actually put this on a different page so we have more space. So square root of 40 over 7. Again, 40 over 7 does not reduce, so I'm going to rewrite this as a square root of 40 over the square root of 7. And just like the last problem, we're going to try to get rid of the square root of 7. So I'm going to rewrite or multiply both the top and the bottom by square root of 7. So 40 times 7 gets me 280, which we'll probably have to reduce. And then square root of 7 times square root of 7 is square root of 49. Now we already know the square root of 49 is 7. But the square root of 280 we're going to have to deal with. So over to the side, let's do our factor tree. I know that 28 and 10 are factors. I know that factors of 10 are 2 and 5. Factors of 28 are 4 and 7. Factors of 4 are 2 and 2. And I've got my prime numbers. 2 times 2 times 7 times 2 times 5 gets me 280. So since I'm doing a square root, I'm going to circle numbers that are in common. These 2's are in common, so I can bring that 2 out. The 7, the 5, and the 2 don't have any pairs, so they're going to multiply back together and stay underneath the radical. So 7 times 2 times 5 gets me 70. So my final answer is 2 square root of 70 over 7.